When talking about sign conventions for a reflecting surface, there are a lot of things that are going to be consistent with what we've already learned with refracting surfaces. The first thing is that light is always going to start out by traveling from left to right. And so distances that we measure from the surface to, in this case, the object, are going to be measured directionally, and if it's against that original direction of light travel, then it's a negative distance. And if a distance is measured from left to right, here from the surface to the image point, then that's going to be a positive direction. Also, just like before, when light is diverging, we say that it has negative vergence, whether the light is incident on the mirror or reflected from the mirror. When it is diverging, the vergence is negative, and when it's converging, the vergence is positive, whether we're talking about the incident light or the reflected light. So for keeping track of which rules are the same, distances that are measured from left to right are positive distances. So another example would be our object distance here would be measured from left to right, and so that's a positive L. Any distance that's measured from right to left we say is a negative distance. So here our image distance from the surface to our image point would be a negative L prime. And then light that is converging, whether it's incident light or whether it's reflected light, has positive vergence. And if light is diverging, it doesn't matter whether it's the incident light or the reflected light, diverging light will have negative vergence. Because of the fact that light changes direction when we're talking about reflection, there are some changes that we have to make to our sign conventions. So the object space for a reflecting surface, just like we're used to, we say has an index of refraction of n. And the reflected light is obviously still in that same medium. So instead of saying that it's also an index of refraction of n, we say that since the light is traveling in the same medium but in the opposite direction, that the image space we're going to now call negative n. And you can actually use this in your refraction formulas. When you substitute negative n instead of n prime, you can use your refraction formulas for reflection. And the other change that you can see here is that when we have a real image, we actually have a negative L prime and negative image distance, which usually with refraction, since a real image is on the right side, it's a positive L prime. But in the case of reflection, a real image is in real space on the left side, and so a real image is going to have a negative image distance, and a virtual image would have a positive image distance. So here, if we have a virtual image formed by diverging emergent light, the image is going to be located in virtual space, and your L prime, your image distance, would be a positive distance.